Okay, today in this video I explain about the counter current mechanism. So counter current mechanism, counter current mechanism. Okay, right. So what is about the counter current mechanism? So counter current mechanism generally helps in the concentration of the filtrate fluid or urine concentration. Okay, right. So generally the mammals have ability to produce concentrated urine. Okay, right. So how it will be, urine will be formed concentrated. Let us explain. Okay, so here generally during in the concentration urine formation, so generally Henle loop of the nephron and vasa recta both are plays a main key role in this to maintain the concentrated urine. Okay, so one is loop of Henle and vasa recta. So both are maintains the concentrated urine. Okay, they play a key role in the formation of concentrated urine. Okay, vasa recta means the blood vessels. Okay, the blood vessels. So this is the Henle loop. This is the Henle loop of nephron. Okay, and this one is the vasa recta. So vasa recta means the blood vessel which is surrounded to the Henle loop. Okay, so that is called as that blood vessels are called as vasa recta. The blood vessels which are surrounded to the Henle loop. Okay, that blood vessels are called as vasa recta. Here these both are play a main role to formation of concentrated urine. Okay, how it formed I will explain just now. Okay, right. Here this is the cortex region of the kidney, and this is the outer medulla region, and this is the inner medulla. So in this region there is a interstitial fluid will be filled. Okay, interstitial fluid is filled in the cortex, outer medulla and inner medulla region. Okay, I think slight confused. I think you have slight confusion, slight doubt. I will explain that. This is, for example, this is the kidney. Okay, here we see this is the kidney structure, and these are the pyramids. Okay, so these are the pyramids. Okay, yes, this is the internal structure. Here we see the this is the cortex region, and this one is the medulla region. Okay, so generally the inner space of the kidney is divided into two regions, so cortex and medulla. Okay, here in the this one is the cortex region, and this one is the medulla region. The medulla region again divided into two parts. Okay, so outer medulla and inner medulla. Okay, right. So here these are the pyramids. So pyramids are generally nephrons. These are the nephrons. Okay, so nephrons are attached on the pyramids. Okay, so this is one of the nephron. So nephron extends from cortex to medulla. Okay, so I take this part. I take this part in this diagram. Okay, I zoom it. This diagram. Okay, this is the ultrastructure of the nephron and vasa recta. Okay, I take this part only, but I enlarged like this. Okay, right. Okay, are you? I think are you clarified? Okay, so this is the cortex and this is the outer medulla, this is the inner medulla. So cortex, outer medulla and inner medulla. So nephron is extends from cortex to medulla. So generally loop of Henle only present in the medullary region. Okay, medullary region. So loop of Henle only present in the medullary region. Okay, right. So now I explain about this. So here we see these two are the plays a main role to formation of concentrated urine. So generally the flowing of renal fluid in the two limbs of the Henle loop is in opposite direction. Okay, so opposite direction. Here we see the renal fluid direction is, so this is one descending limb and this one is the ascending limb. So Henle loop has two limbs. The flowing of renal fluid, filtrate fluid is in opposite direction, like this and like this. Okay, opposite directions in two limbs. Okay, yes, so this forms a counter current. Okay, this forms a counter current. Counter current means nothing but flowing of renal fluid in a opposite direction. So opposite direction is called as counter current. Okay, right. At the same similarly here also this is the vasa recta. Vasa recta also has two different limbs. That is this one is the descending limb and this one is the ascending limb. Okay, so this one is the descending. Okay, yeah, descending limb and this one is the ascending limb. Okay, yes, here also flowing of blood also counter current pattern. Okay, that means flowing of blood also in opposite direction at the two limbs here like this. Okay, so these two renal fluid, here we see renal fluid and here we see the flowing of blood, both are moves like a counter current pattern. So this counter current pattern generally maintaining and increasing the osmolarity towards the inner medullary interstitium region. Okay, right. So these two opposite direction of the flowing opposite direction, the flowing renal fluid and blood is in opposite direction, makes a counter current pattern which creates the maintaining and increasing the osmolarity towards the inner medullary interstitium. Osmolarity will be increased. Here we see that is 300 osmolarity in the cortex. Okay, is about 1200 osmolarity inner medullary region. Okay, so 300 osmolarity in the cortex. That is about 1200 osmolarity in the inner medullary interstitium fluid. So osmolarity will be increases. Okay, so counter current pattern increases the osmolarity. So this gradient is caused by NaCl and urea. Okay, so this gradient is caused by NaCl. So NaCl and urea. Okay, so both are increase the osmolarity in the interstitial fluid. Okay, right, the kidney. Right. So here we see NaCl generally comes from the ascending limb of the Henle loop. This is the ascending limb. This one is the ascending limb. Okay. So NaCl comes into the interstitial fluid through the ascending limb, and it will be enter into the descending limb of vasa recta, and then it comes into the interstitial fluid again, come back into the interstitial fluid by the ascending limb of vasa recta. Okay, are you clear? So generally NaCl comes into the interstitial fluid by the ascending limb of Henle loop, and then it will be enter into the descending limb of vasa recta, and then come back into the interstitial fluid by the ascending limb of vasa recta. Like this, NaCl is deposited in the interstitial fluid, interstitium. Okay, medullary interstitium. Okay, and a small amount of urea will be enter into the this ascending limb of Henle loop, and few amount of urea come back into the interstitium by the collecting duct. Okay, small amount of urea enter into the ascending limb of Henle loop and come back into the interstitial fluid by the collecting duct. Like that, the amount of urea also deposited in the interstitial fluid. Okay, like this, NaCl and urea also deposited in the interstitial fluid, that increase the osmolarity gradient. Okay, so like this, the urine will be concentrated. So this makes the urine concentrated. So just once again I explain clearly how it maintains the concentrated. So when the gradient will be increased in the interstitial fluid, then when we compare to the Henle loop, renal fluid of the Henle loop, okay, here the concentration will be increasing. Okay, here the present concentration will be increased, osmolarity will be increased when compared to the renal fluid of the Henle loop. Okay, then what happens? Generally, water comes from lower concentration to higher concentration. Water reabsorbed from lower concentration to higher concentration. That is base of osmosis. Okay, like that. So, a lot of water will be comes from renal fluid into interstitial fluid. Okay, then what happens when the lot of water will comes into the interstitial fluid? Then the renal fluid become a concentrated. Only salts only present in the filtrate fluid, renal fluid. That makes the urine concentrated. Okay, are you clear? Yes, when the osmolarity will be increased in the interstitium, then here when we compare to the Henle loop renal fluid, the osmolarity will be decreased. So then the water will be comes from lower concentration to higher concentration. It moves from lower to higher concentration. Then what happens? The water will be decreased in the renal fluid. Then it becomes a concentrated. Okay, right. So like that, the NaCl and urea in the interstitial medullary fluid, it maintains the osmolarity and makes the urine concentrated.